Sekejap. Kalau tak nampak.
Baru nampak.
Sekarang nampak.
Sir.
Tapi dia tak full screen
Oh.
Salah saya stop dulu. Okay, sekarang okay kan? Boleh nampak kan?
Nampak sir.
Okay.
Boleh, sir.
So last week you already learned about force and electric field. So I assume you guys have tried to do some of the tutorial questions. So force is F, electric field is E, and the most important part is that these two is a vector. Okay, so these two are vectors. So you will expect this one has direction lah. So when you try to do calculation or the calculation, you have to determine the direction first. Sebab tu saya selalu suruh lukis free body diagram. When I say free body diagram, it looks something like this lah. Object, kita letak sebagai point and then ada force ataupun electric field punya direction. It could be F, it could be E lah. Okay. But today, what we're going to learn is about a scalar quantity. So in the next few chapter, 11.3 ni, subtopic 11.3, we have a potential. I'll just summarize a little bit the quantities that we learn. V, and then we have work, and then we have U. Okay, so all of this is actually a scalar quantity. This one is KQ over R squared. This one is Q naught delta V, and this one is KQQ over R. This one is over R, right? So that is. Oops. Okay, so all of these is scalar quantity. So when I say scalar, you have to substitute the negative sign inside the equation. Substitute negative or positive inside equation. And then the positive and negative actually it will mean something lah. Nanti saya tunjuk one by one. Contohnya work positive and negative ada maksud dia. Potential positive negative pun ada maksud dia. Nanti we go through one by one lah. And then one more thing is about Q naught. Q naught ni ramai we get a little bit confused. This one is just a test charge. Okay. Again, I will explain this one in details soon lah today. Okay, so today we're gonna learn about these three main quantities. Okay, and then the last subtopic will be about charge inside a uniform electric field tu nanti lah later on. So we focus on these three first. Okay, kamu dah ready belum?
Mari kat kau.
Ready saya.
Ready
Ready, sir.
Okay.
Nah, saya.
Okay, so learning outcome for today, at the end of this chapter, students should be able to define electric potential, V equals to W over Q naught. That one is from the definition. Define and explain equipotential lines. Kena lukis jugalah. Use 4-point charge and a system charge, V equals to KK over R. Calculate the potential difference, deduce the change in potential energy, delta U, and then U, maximum 3 points. Okay. Itu objective je lah. Then this one is the content dia. Electric potential of a point in an electric field is defined as the potential energy per unit positive charge at that point in the electric field. So this is the definition. So definition is this one. So you can write in terms of formula lah. So the sentence actually explains the formula. Potential energy U per unit positive charge. This one is Q naught. Notice that this one is per unit positive charge. Sometimes kita pakai per unit positive test charge. Dia kadang-kadang dia letak nama test lah. But it means that this one adalah positive charge. It's defined as the work done per unit charge in bringing positive test charge from infinity to that point in the electric field. Okay, so the second one is a little bit longer, the punya definition, but it still explain the same thing. Cuma satu ni V equals to U over Q naught, and this one is V equals to W over Q naught. Biasanya kita pakai yang bawah ni, yang atas kita kurang sikit pakai. W over Q naught means work over Q naught. So sebab tu kalau kamu nampak kat sini dia sebut pasal work dan positive test charge. Yang ni dah disebut positive test charge kat atas, tak sebut kat test lah. So saya letak lah. Saya rasa dia tinggal ni. Okay. From infinity to that point in the electric field. Okay, aku nak explain more on this one. And this one saya tak explain more. Sebenarnya U potential is equals to work. So kita boleh formula dia ada dua macam tu. So what does it mean by this definition is actually, let's say if I have a positive charge. Ini yang charge Q. Okay, I'll put a capital Q lah. Okay, this charge Q is in isolated system. Dia by itself dia memang ada seorang kat situ. And then if you look at the definition, it's the work done in bringing positive test charge from infinity to that point in electric field. Okay, let's say if I have a positive test charge, I put this one as plus and I put this one as Q naught. Okay, from infinity. So initially the R is equals to infinity, and then it brings from the infinity to that particular point at certain point lah. So let's say I put it over here. R, let's say, equals to A. This is the distance from Q naught to this point lah. So actually the formula work is equals to, later on you'll learn about this, delta V. Okay, so delta V here means final potential minus initial potential. Dia mesti final minus initial, depends on the motion lah. Kalau dia gerak daripada infinity ke A, final dia A. Kalau dia gerak from A to infinity, final dia is at infinity. So if I try to open up the V here, it will be V final minus V initial. And then another formula that we learn is about KQ over R minus KQ over R. So initially, it is at infinity. So here is actually at infinity from the diagram here. So if you have a term that over infinity or over a very large number, so that one is actually equals to 0. This one is equals to 0. So if this one is equal to 0, then this one is basically just Q naught KQ over R. So actually I have to write this one equals to Q. Okay, this one is the charge that is moving, and this one is the charge that is not moving, yang fixed. So the potential, actually, the source of the potential is from this Q. So this one is just a V, so Q naught, so it's equals to work. So that's why I can write V equals to work over Q naught. So just a rearrange. So this is just the definition. And nanti kita akan relatekan the V with the Q, but for now, this is the definition lah. If you want to write in terms of sentence, you have to include from infinity to that point. And so this is important keyword lah kalau dalam exam dia tanya. But I expect this one they will ask in objective. So tak ada masalah lah. Okay, so scalar quantity, the unit that normally we use is watt. Joule per coulomb is also correct, but normally we use watt lah as a unit. Okay, any questions so far?
No, sir.
No, okay.
No, sir.
So we're moving on to the next one. Is how we want to draw the equipotential lines. So actually, what is equipotential lines? Change the ink color first. Okay, equipotential line is actually, I cakap tak? Oh, dia tak cakap. Okay, equipotential line indicates that electric field at every point on equipotential surface is, bukan, salah. Okay, equipotential line indicates potential at each position lah. So this one, kalau E ni dia indicates the direction of electric field, equipotential line ni dia indicates the magnitude of potential. So you will notice that electric field yang solid line ni is actually 90 degrees to the equipotential line. Yang dotted line ni is equipotential line. Kat atas dia tulis pun. Okay, so this one is actually the dotted line too. If you have 2 points which is on the same equipotential lines, it means that it has the same potential. V dia sama lah. So in this case, I can write VA equals to VB. Okay. So let's say if I want to draw a graph for this one. Katakan saya nak graph katakan saya lukis kat sini. So if you guys masih ingat tadi just now, the formula V is equals to K Q over R. Q is this charge. So katakanlah saya I want to draw, let's see if I want to draw a graph. Okay, so potential against distance R. So initially it is positive, and then as the radius is increasing, the potential is decreasing. So the relation is actually in this case 1 over R. So as it goes further away, potential will be decreasing. So how do you want to indicate inside your diagram? You will see that the line that is closer together, macam ni rapat-rapat kan, that one indicates higher potential. Further distance means lower potential. So you just want to indicate lah. Biasanya dekat tengah ni kita buat rapat sikit, kat ujung tu kita buat jarak sikit. And the key thing, if they ask, normally they will ask to draw equipotential line together with the E. So when they ask to draw, make sure E to always 90 degrees to the equipotential line. Dekat sini 90 degrees. let's say 90 degrees. This is actually an example of if you have a uniform electric field. So if you want to have uniform electric field, normally you will have two metal plates. Saya seperti lukis kat sini, dia tak muat. So I draw it on top of the diagram. So let's say if I have two metal plates, this one is positive plate, this one is a negative plate. So then only I can have a uniform electric field. So this one is actually example of point charge, how the equipotential looks like. And this one is example of uniform electric field ataupun electric field between two metal plates punya equipotential. Sebab electric field dia uniform, potential dia pun common expect to be uniform lah in this case. Okay, so yang this one, kalau dia negative, let's say if the charge here is negative, you still have pretty much the same equipotential. Punya lines tu nampak sama je dengan negative. Just that for negative you have E ni inwards lah. Okay, one thing about this characteristic, so VA is equals to VB, kan? So you expect VC ni actually less than both VA and VB. Normally in exam, let's say dalam objective question lah, biasanya dia akan tanya how much work is required to move object ataupun charge from B to A. So they want to move from B to A. So you notice that VA is equals to VB. If I want to write the work equation, okay, so remember that this delta V is actually final minus initial. So let's say if my work done to move from B to A, then I have to write VE minus VB. VA minus VB. Final minus initial, jangan lupa keynote tu. So in this case, VA is equals to VB since it comes from the same equipotential line kan. So this one will become 0. So this is the important characteristic lah. So if you want to move a charge from one position to another, if it is in the same equipotential line, ni masih lagi line yang sama tau, cuma dia berpusing macam tu, the work required is 0. Okay, kalau kamu nak gerakkan dia across ataupun over to the next equipotential line, then you have to apply some work. It will be either from the work will come from the external or by the charge. Itu nanti kita pergi. Okay, this one is just the one that I told you before. Surfaces are closer together. Electric field is stronger. Equipotential line does not intersect with one another. This one is work BA yang equals to 0. This one is the results of those diagram. No work is done when the charge move from one point on an equipotential surface to another point on the same surface. So kalau sama line, no work. Remember, because the potential difference is 0. Okay, this one. Okay, remember that I told you that potential is scalar quantity. So for scalar quantity, if you have a negative, you have to substitute the negative sign inside here. Okay, so this one is positive, this one is negative. Biarkan macam tu. What does the negative means? Actually, it just means that the potential comes from a negative charge. So negative here means potential comes from negatively charged particle. Kira source itu adalah negatif lah. Okay. One thing that they already took out from your syllabus is the graph. So saya sebelum school ke graph, so saya mesti tunjuk apa yang dah keluar daripada syllabus kamu. So the main difference between this one and this one is actually from the graph, positive and negative kan. So the relation here, I can write this one as V directly proportional to the 1 over R. But here it becomes V directly proportional equals to 1 over negative 1 over R sebab dia ada negative tu. So the difference in graph, it will look something like this. One is positive, and that saya tunjuk tadi. Another one is like this. So graph 1 over X is actually macam ni lah. Kalau positif dia ada partner yang bawah ni, tapi kita tak akan dapat radius negatif, so we just focus on this part. Kalau yang this one, kita ada partner kat sini. Again, kalau negatif kita ignore. So this one is V, this one is R, V and R. Okay. For the first part here, if you increase in radius, you have decrease in potential. For this one, if you increase in radius, you have increase in potential. It's just that this one is from further negative, this one is closer to 0. But the main trend here, as R is increasing, it approach 0. Kedua-dua ni approach 0, this is the main trend. But here, be careful, this one V is decreasing, this one V is increasing. Okay. Okay, this one is what I'm talking about lah. So, since your company syllabus dah keluarkan graph, so instead of putting the graph, they actually put sentence like this. Tapi sebenarnya sentence ni come from the graph itself. So, kita belajar je lah graph tu. V increase as you move inward, V decrease as you move outward. As per the graph I showed you just now. Decrease, move inward, increase as you move outward. Again, come from the graph as well. So this one, if you try to write K with a different constant, okay, kalau kamu nak tulis K itu dalam bentuk berbeza, walaupun for no reason, so biasa kita pakai yang this one je lah, V equals to KQ over R. Okay, kita try the example. Let's pick the next one. Okay, we discuss the example first. Okay, so far, any question?
No, sir.
Okay. For example 1.6, 2-point charges Q1 and Q2 are separated by a distance 15 cm as shown in figure 1.14. Calculate the electric potential at point A and then at point B. Okay, so they give you the diagram like this. Kalau this one is a vector quantity, contohnya kalau F atau E, kamu dapat soalan je, kamu mesti kena lukis arrow dia ke mana. Contohnya force dia direction ke mana dekat A tu, electric field kat A tu ke mana. But because this one is a scalar quantity, you don't have to bother with the direction. Jangan risau pasal direction lah, because this one no direction. So what you need to do, electric potential at point A is basically summation of all the potential at A. Now you have to ask yourself, how many charges are there in the diagram? Ada berapa banyak charge kat dalam diagram ni?
Dua.
Ada dua kan? Okay, since there's a 2 charge, so you will expect you will have 2 potential. One potential will come from the first charge at A. Another one will come from the second charge at B. Sorry, at A juga. Maafkan saya. So this one, actually if I want to draw equipotential line, contohnya saya nak bagi equipotential line kan. Di sini saya ada satu, and then saya ada sampai sini lah. So that means yang Q1 ni akan produce electric field, like that. And then equipotential line dia pun macam ni lah. So kalau yang ni pun akan produce electric field inwards and then akan ada equipotential lines. Sebab tu ada dua potential over there. So I'm going to erase that one. So I just want to show you the source of potential in case kamu tak nampak. So setiap satu charge dia akan produce satu potential. Okay, kalau charge tu dekat dengan, kalau point tu dekat dengan charge, biasa memang potential tu akan value dia nampak besar lah, number dia tu. Okay, anyway, the second part, electric potential at point B, you have 1 at B plus 2 at B. Okay, the key thing here is that first you need to substitute negative value tu kena masukkan dalam equation. That's the first important part. The second one, you have to use the correct R. So you know that V is equals to K Q over R. Q ni mesti daripada, kalau when we are talking about Q1 then Q1 lah, Q2 Q2. R here means the distance from here, R1A, R2A, yang B itu should be R1B, and this one is equals to, and it's important as well, and then charge tu mungkin masuk negatif. Macam mana nak kira? Senang je, masukkan dia semulai, tak payah fikir direction. So for the first part ni dah ditunjuk, the electric potential at point A is simply tambah, okay, dia factorkan K ni, you can factor that one as well, and then when you substitute the charges, make sure you include the negative sign. So this is a really important things to do lah. Include negative or positive sign. Kalau positif tak perlu tulis lah. So negative you include, and then kalau satu negatif satu positif, so negatif positif lah. Tapi dua ni adalah negatif, so negatif just write inside your equation and final answer kena ada ni. Okay, let's say kamu terlupa, and then final answer kamu memang akan salah lah sebab tak ada negatif tu. So memang kena masukkan. So you will lose 2 marks. So biasanya gantian mark kat sini, and then final answer will unit over here. So normally they will give you 2 marks for this one. Okay, the next one, yang B tu, of course you have to find R1B first. That one is just a Pythagoras. So dikira kat sini. And then to solve this one, again you basically use the same method. Again, masukkan nilai negatif. Penting, this one is penting. Okay, itu dia. Okay, electric potential difference, delta V. Potential difference between 2 points in electric field is defined as the work done per unit charge in bringing a positive test charge from a point to another point in the electric field. Okay, dia punya definition very similar to V lah. Consider a point's positive test charge is moved by the external force F. Okay. So this one, saya dah tunjuk masa yang dekat V tadi punya definition. So this one, they just want to consider positive test charge is moved by external force F from point B to point A, B ke A. Cuma kalau yang tadi tu, when I try to show you, I give example of infinity to point A. Okay, kalau yang ni dia a point to another point, that's the difference lah, delta V. So kalau yang ni, point here ada nilai, potential dia ada values from B to A. Because we are bringing from B to A, so dia mesti final minus initial, so final dia dekat A, initial dia dekat B, okay. So A minus B lah, like this. work B. A is work done in bringing positive test charge from B to point A. Okay. If the question want you to find work, katakan soalan dia ada relation with work kan. So delta V ni, dia mesti final minus initial. So I'm gonna write it again over here. Okay, but sometimes in exam, the question just want you to find potential difference. Kadang-kadang So if the question just want you to find potential difference, you can calculate using V. Kalau ingat, kalau soalan tu tak ada kaitan with work, you can calculate VA minus VB or VB minus VA, because the question just want you to find the difference. Tak kisahlah B tolak A ke A tolak B. Dua-dua diterima. Satu tu ada positif, satu tu akan jadi negatif lah. In exam, dua-dua diterima. Remember jangan pening-pening. Tapi kalau dalam soalan tu, they ask you about work, kata yang kat soalan tu ke, soalan lepas tu ke, biasanya you have to consider final dengan initial. Bukan biasanya, you have to consider final dengan initial tu. So, itu the difference. Biasanya, kalau nak senang, semua kita buat final minus initial. But then, kalau dia cari delta V je, dia tak akan cakap final dengan initial, dekat mana kamu yang kena tentukan A tolak B ke B tolak A. Apakah ini? Oh, this one just cakap je lah VB dengan VA tu. Tak ada apa ya. Okay, so electric potential delta V A. Kita kamu pelik sikit. Okay, so dia ulang balik. Cuma sekarang ni sebenarnya dia nak cerita pasal work. Pelik Sebenarnya actually this one they want to cerita pasal work. So I want to put this one as work punya subtopic. Okay, the work done to bring a charge from one point to another point in an electric field is independent of the path. So maksud dia kat sini, contohnya katakan saya ada positive charge kat sini. Kalau kamu perasan kita ada satu potential line and satu lagi potential line. Okay. Katakan we are talking about point A and point B. So kalau saya nak buat charge from B to A, maksudnya kat sini I can go like the I can go like that, pergi situ ke, saya boleh pergi straight ke situ atau berpusing-pusing pergi ke sana. It doesn't matter. So the important part here is initial and final position dia. Nilai kerja yang dilakukan adalah sama. So the work done is the same regardless of the path. So independent of the path, remember dia tak penting. Dia bukannya macam work sama dengan FS. So S is important kan. Tapi yang ni dia adalah independent of that. Actually S pun displacement. If the value of work done is positive, it means that the work done on the system. Okay. If the value of work done is negative, it means work done by the system. I will explain more on this. Kenapa dia on dengan by. But for now, ataupun kalau kamu nak senang lah, kalau kamu susah sangat nak faham, you can simply memorize this two lah. Biasanya dalam exam, dia tak banyak markah pun untuk this part. Kadang-kadang dia tanya, contohnya dia dah suruh kira work, lepas tu last sekali state whether the work is done by the charge ataupun on the charge. And then biasanya dia tak tanya pun, so hilang. Dia tak ada markah sangat lah kat sini. So kalau kamu rasa susah sangat nak faham, kamu boleh hafal. Tapi jadi saya explain apa maksud dia. Okay, consider a positive test charge is moved by the external force F from point A to point B as shown. Okay, for this one, okay, this one kat sini actually dia maksudkan, you can try to draw the graph again so that you can see. This one is a positive, oops. Okay, so this one is a positive charge. So you expect the graph will look something like this. It will decrease lah daripada high to low. So here, it looks like VA is somewhere over here. Sebab jauh kan, VB tu dekat. But the motion would be from A to B. Okay, so this one, yang graph saya lukis ni actually depends on the distance. You can see here that A is actually further away from the positive charge. So A tu kat belah kanan lagi lah. Yang B tu closer to the positive charge. Now, the work done is to bring from A to B. B has higher potential compared to A, like this. Okay, so if you try to calculate work equals to Q delta V, like this, so this one will be positive because B is bigger. Okay, sebab final minus initial kan, dia tak ada tulis betul-betul lah. So work equals to Q delta V. I don't know why your notes they like to write yang delta V equals to like this. Biasanya kita pakai yang macam ni lah. B tulis macam ni pening. So work equals to Q delta V, where delta V is actually this one is Q naught. Q naught V final minus E V initial. In this case VB minus VA. Since VB is bigger than VA, so this one will be a positive value. Okay. Sini positive. Sini positive. So work done is positive. So positive. Okay. So here they already said that it need external force. So it makes sense lah. Positive means work done on the system. Kalau kita pergi balik kan. Positive is work done on the system. Need external force. So it makes sense. So yang ini sebenarnya dia explain yang atas ni. Tapi saya tak tahu kenapa dia menyusahkan diri explain macam ni. Anyway, if you want to think about logic, you have a positive charge that is not moving. Yang ni kita pakai Q tau. This Q, if you want to substitute, the value would be inside V ni. Contoh kita nak kira delta V ni kan, you have to calculate VB dengan VA. VB dengan VA depends on this Q. So contoh if I want to write V equals to KQ over R, I have to use this Q. This Q naught is actually the test charge, is the charge that is moving. Yang bergerak tu kamu letak luar daripada delta V tu. Bila kamu kira, since this one is a multiplication, mana-mana graph. Okay. Kadang-kadang student tertukar dekat dalam mana, dekat luar yang mana. Maksud saya, dia kira delta V tu dia terpakai Q naught, dia kira yang dekat sini dia pakai Q. Final answer memang ke sama. But then you get it wrong because concept is wrong. So be careful with that. Jangan salah konsep. Jangan salah substitute. Yang tak bergerak is the source of the potential. You substitute inside here. The one that is moving is Q naught. Okay. Dia memang label lah. Tapi dalam exam biasalah sometimes kita terlupa. So dalam exam dia tak ada label-label macam ni. So very selalu student terlupa. Okay, back to the logical thinking that I I said just now. So if you have positive charge and positive charge, okay, you want to move two positive charge closer together. Kamu nak rapatkan dua positive charge, you have to apply some work. Logik lah kan, kamu ada dua magnet yang sama kutub. Kalau kamu nak rapatkan, you have to apply some force. Same apply over here, because by naturally they will try to repel each other. So if you want to bring closer together, you need to apply some work. That's why you have a positive work over here. So it makes sense. Okay. So dalam exam, kan saya cakap tadi kan, kamu boleh hafal je positif maksud apa, negatif maksud apa, or you can think about logic like this. Positif nak rapatkan, or you have to apply some work, ataupun kamu boleh tengok from the calculation tu. Ada tiga cara lah kamu nak faham apa maksud positif negatif tu. Okay, and this one is just again, you still have a positive charge dengan positive charge. Cuma dia nak tentukan satu tu, yang A ni dia gerak from A to B, yang this one dia gerak from B to A. Okay, so they try to think by logic lah. Saya highlightkan this one. So if I want to move from A to B, I'm going to put arrow over here. So I want to bring two positive charge, two equal charge closer together. I have to apply some work. Okay, so need external force. So you will expect the work done is positive. Okay. Okay, this one is work done by the external force lah. Sentence ni saya tak suka. Saya tak faham boleh tulis apa. Okay, from lower to higher electric field potential energy charge will increase. Okay, V dia pun positif juga sebab again, if you have a positive charge, your graph should look something like this. This one is B, closer to the point charge. This one is A, further away. So kalau saya nak gerak from A to B, B is bigger than A. Kalau saya nak gerak B ke A is lower than B. So the next one, if I want to move the test charge from B to A, the arrow will be something like this. Since this one is equal charges, you will expect they will try to repel each other naturally. So the work done is actually by the system. Kalau kamu letak rapat, kamu lepaskan dia pun dia bergerak sendiri. Itulah seakan-akan macam tu. So this one is negative work done. So dapatan yang penting from here is this one is positive example. This one is the example of negative. That means you don't need to apply any work. Okay, the one that is doing the work is actually the charges itself ataupun the system. So system ni buat kerja, this one adalah negative. This is what it means by negative and positive work. So what if I have a negative charge? Using the same concept yang sama, except now I have a negatively charged particle ke tengah tu. So my graph would look something like this. Again, B is closer, A is further away. So dia just terbalik sikit je lah. So here in this case, if I want to move a positive charge closer to the negative charge, macam ni kan. So you expect, because this one is positive, this one is negative, the work done is by the system. Naturally, you try to move together by itself. Okay. So if you move from A to B, so B is actually have a lower potential compared to A. Macam ni lah. VB is lower than VA. The second example here, if you have a positive charge, you try to move it from B to A, opposite charges you want to bring further away, you have to apply some energy. So that's why it becomes a positive work. Kamu okay tak ni?
Okay, sir.
Okay.
Okay, sir.
Okay, sir.
So for this one, you will see, okay, so from this one, you will see that VA is actually higher than VB. So VA is bigger than VB. Itu je lah yang dia nak sebut. But remember, this example, okay, this example and previous example, actually they show you about positive test charge. Ada tak ada contoh kalau negatif? Anyway, kalau negatif dia terbalik lah. Tapi the main concept is like that. If I want to bring equal charges further away, the work done is by the system. If I want to bring equal charges closer together, that means you have to apply some work. Tapi ingat dalam exam, dalam kita punya syllabus, yang bergerak tu satu je. Lagi satu tu adalah fix. Yang fix tu adalah capital Q, yang bergerak tu adalah Q0. Itu je important thing yang kamu kena ingat. Lepas ni kita ada U. Okay. I just try to explain how to do the calculations, and then maybe you can try to look at the solution yourself. Okay, 2 point S and T are located around a point charge of positive 5.4 nanocoulomb. Calculate the electric potential difference between point S and point T, and then the work done in bringing a charge negative 1.5 nanocoulomb from T to S. Okay, dia sebenarnya ada dua soalan. Question number 1, obviously ada dua soalan kan. Question number 1, they want you to calculate electric potential V. Okay, the first one they want you to calculate V. The second one they want you to calculate work. Electric potential difference between 2 points actually is delta V. Okay, ingat saya cakap kalau dia cakap delta V, dia tak akan cakap daripada mana ke mana. They just want to find the difference between S and T. And saya cakap kalau dia tak ada tanya pasal work, it doesn't matter kamu nak buat mana-mana. In fact, this one tak kisah kamu nak buat mana-mana. But you have to think smart lah kalau dalam exam. Kalau kamu tengok the next question, dia kata the work done in bringing a charge from T to S. So eventually, if you want to calculate B ni, work equals to Q not delta V, you have to do work equals to, okay, you have to calculate Q naught. Delta V here would be final minus initial, so the T to S, so it would be Vs minus Vt. So since you want to use this value over here, can might as well you calculate over here is Vs minus Vt, so that it will help sound. The next one kamu nak jawab, you can use the value straight away. If let's say over here you calculate Vt minus Vs, it's still correct. Just that when you try to substitute over here, you just have to put negative, which biasanya student memang terlupa lah. So be careful about that. So it's up to you lah nak buat yang mana. And then, okay, here, kalau dekat soalan A, you only have one charge. Okay, charge ni fixed. This one is your source of the potential. Okay, we label this one as Q. Capital. The one that is moving, like the question B ni, the work done bringing a charge from T to S. So that one is actually, they add another charge over here, that is Q naught, and they bring it from here to here. Okay. Since the distance between this one and this one has a different length, kamu boleh nampak this one actually longer, this one is shorter. So this one is actually RU. RT, and this one is actually RS. Okay, so you can see that S is actually shorter lah, so you expect the potential would be different as well. That's why kita akan ada applied some work. So solution dia senang je. Yang part A tu just have to substitute charges for Q tu KQ over R. Here dia pakai T tolak S. Kalau ada negatif, remember if the charge is negative, you just have to substitute Q tu sebagai negatif. Tapi yang ni adalah positif, so tak adalah. Okay, final answer dia dapat negative 324 volt. Obviously this one depends on whether you do VST atau VTS. Then the next part, they want to calculate again, company lecturer suka pakai V equals to something. Okay, this one is actually work equals to Q naught delta V. Sama je, cuma dia rearrange, dia jadi delta V equals to work over Q naught. Misalkan diri. So delta V tu, dia kira tadi just now is ST. So if you want to use ST, you have to put negative tu kat sini. So satu kau perasan, if you notice, this one is actually TS yang sepatutnya, so dia nak bawa daripada 3S kan. Tapi sebab dikira terbalik tadi, you have to put negative there. Ni yang saya cakap lah, so you have to think smart when you try to answer the question. Then masukkan je nilai and then should get the answer. Notice that Q naught here ada negative. So this one would be apa ni? Including calculation. Again, for scalar quantity, if you have a positive or negative sign, just put inside the calculation. Okay, what does it mean by negative here? It means that the work done by the system. Okay, once you finish, normally you want to check whether your calculation is correct or not, whether it makes sense or not, just check. So I have this example, Q naught here is a negative charge. Okay, so this one is positive. So initially you have further away, final is actually closer together. So when you try to bring from T to S, you actually bring an opposite charges. Charge yang opposite, kamu nak bawakan dia closer together. So obviously that one is work done by the system, so it makes sense. You get this one as negative. So biasanya dalam calculation work tu, common mistakes, student tersalah substitute Q naught tu, dia confuse Q naught tu yang mana. And then the second part is that sign positive negative tu, kalau salah tu maksudnya terbalik lah tu delta V dia. Okay, so I'm gonna stop now sebab tak sempat nak masuk yang the delta U tu. Tapi delta U tu sikit je, so we can discuss that one in our next class. So any question for now?
No, sir.
Okay, no. So if there's no question, maybe we can stop here today. Okay, thank you everyone.
Thank you, sir.
Okay, alright.
Thank you, sir.
Thank you,
Okay.
sir.
Thank you, sir.
Okay,
Thank you, sir.
okay.